surface you get back once like that. Here you see, my target is this is 38.25 line on the 3 parameters. So if you see here, this is compressive strength, this ratio, A is alkaline percentage, that is coming around 4.5 or something. Then molarity, if you see, best one, between 10 and 12, and this ratio in between this ratio, where it is intersecting that one. So these parameters we have taken for this one. Next. Next. Similarly, we can do it for split tensile strength. Next. Next. Same way, you can skip. Continue. Continue. This is for modulus of elasticity, right? Next. This next one is for dynamic modulus of alpha UPV. You can see UPV. Next. This is for dynamic modulus of elasticity. Next.
After that, we will have a question answer.
Yeah. Next. Next. You can derive mathematical equation. These equations can be obtained, and you can see the validation for this equation also. Next. R square values, when you calculate, is almost 0.95, 0.86, 0.88, 0.95. Last values are also corrected later. Actually, those values are slightly disappointing. Then we verified again. We got that also close to 0.9. These values are the R square values. Next. Now you can see the predicted values and the actual values are almost in good agreement. Next. This is for flexural strength and static modulus of elasticity. Next. Next. So from this, height desirability is achieved 0.786 and corresponding values of A equal to 11.6. What is A? Percentage of mineral admixture, alkofine. Molarity is around 12 molar. Then ratio is 1.5. Next. Now you see the validation. Predicted versus experimental, all parameters, major mechanical properties, compressive strength, split tensile strength, flexural strength, values predicted and experimental values. If you see the percentage error, how much? Maximum error is only 4.64%. It is less than 5%, which is acceptable. So what you can understand that model, mathematical model is doing good. Next. Phase 2. Okay, skip. Next. Next. Comparison of heat curing and ambient curing. Next. You can see this one. Static one experiment, if you see, compare between ambient curing and heat curing, which is showing you better result, ambient heat curing. But of course, you have to spend money to get that temperature. Next. This is the effect of elevated temperatures. Quick. You can see I am comparing the performance with respect to conventional concrete and GPC. Most of the times your GPC is showing better results for all the exposure durations and all temperature exposures. You can see blue line stands for GPC, red line stands for conventional concrete. Blue line is showing most of the times it is above the red line only. That indicates that your GPC is doing better when it is exposed to temperatures. Next. Now you can see the specimens that are exposed to 800 degrees centigrade. This is a picture taken immediately after the withdrawal from the furnace. After exposing the specimens for 3 hours at a temperature of 800 degrees centigrade. You know, when the furnace is loaded with these specimens, to reach 800 degrees centigrade itself, it will take 4 to 5 hours. At that temperature, we are keeping these specimens for 3 hours. This is how the specimens become. Next, you can see one sample exposure to 800. Next, these are 700 exposure specimens. Next, you can see the color change if you closely observe. Next, see the color change. Next one. Next, okay, here actual back. Okay, next, okay, next. See, this is conventional concrete, gray color. These three are the specimens that are exposed to 700. Next, next, back. You see on the left hand side you have got 700 exterior, right side 800. What is the difference? Up to 700 there is a core concrete which is still not changing its color. Conventional color is there, isn't it? Core concrete. You can see this is grayish, this central portion. But when it is 800 exterior, even the core also changes to different color. Next, water absorption test, these tests. Okay, skip. These are thermogravimetric and differential thermal analysis results. Next. These is another Fourier transform infrared spectroscopy results. Next. This is X-ray diffraction, geoform concrete. Next. This is SCM EDX analysis. Next. Continue. These are chemical compositions, right? Whatever I have discussed in the conclusion, those are the points of time. Go next. From phase to phase 3, important points. Next. You are waiting for this. Thank you. Please ask some questions. I have come from Visakhapatnam.
Curing, sir. Generally, OPC concrete at 28 days it gives 90% of strength. What about GPC? Is there any relation between 7 days, 3 days, 28 days strength?
It is still to be established, means not yet. What you said is there are 28 days till 90% hydration will be completed and its strength is expected. Only it is picking up. I think we need to gain sufficient experience before jumping to conclude like thumb rules like that. We need some more time.
Thank you, sir.
But definitely it is relatively slower compared to this.
Thank you, sir.
Sir, we have a OPC how to mix the concrete mixes. For the geothermal concrete also we have instructions to mix, how to mix like that.
Everything is experimental because there is no code of practice.
Sir, you have given the pan mixer we have to use. No, sir?
Yes, that is also from experience only. Because we have started with this one that is sticky. Metal is more sticky.
Yes,
It sticks to the wall of the conventional conical drum, tilting type. So we find it very difficult. Then some visitor from IIT is there suggested you should not use this one, you have to use pan mixer. This has happened almost 8-9 years ago. Then onwards we started to work on pan mixer. That is doing good results.
So it is available in the market.
Yes, it is available. Emil product only.
Sir, for we have to mix some solutions like NaOH in this. For that, when you are mixing NaOH, we have to use some glass pellets like that. We have any certain.
That's the problem. It is budding stage. You have to refer the literature. There is no clear-cut guideline. That's the problem. See, you are completely eliminating the cement OPC consumption. So obviously, you need a lot of experimentation. There are no proper guidelines. Published guidelines are not there. Just for if you see national guidelines for self-compacting concrete, like that, they are well established. But for this type of concrete, you have to reach to that stage. Preliminary it is that.
Thank you.
Hello sir, I'm Sudhir from List University. So my question is sir, you have mentioned geopolymerization is starting at a very high alkaline medium. So is there any particular pH we have to maintain?
There is also an impact variable. It should be alkaline material, that's all.
Yes sir.
Nothing. I have seen from 8 to 12 people are using.
Yes sir.
8 to 12. From literature, whatever doubts you are asking, same doubts I too have. Slowly we are eliminating one by one.
Sir, you have mentioned another thing is Na2SiO3 to Na2
Ratio.
how to maintain that ratio by means weight wise or in mass wise, how to consider that ratio?
Can you ask it again? I don't understand.
You have
You are
mentioned-
talking about ratio.
You have mentioned an Na2SiO3 to ratio. So how to maintain that ratio? If we are adding to, let's say,
By weight only.
how to calculate? It is my doubt.
You see, that total door material you have, how much alkaline medium you have used, you should be knowing. From that I will divide in that ratio. 2 meter.
Yes, sir.
That ratio I will maintain. That's all. You are talking about making the solution.
Yes, sir. Alkali activator.
Yes,
Yes, sir.
I will maintain that in that proportion I will add those 2 ingredients.
By molar weight, sir. Okay, sir. Thank you.
Chemistry,
Okay, sir.
anymore. They are all hungry. Hungry stomachs.
Any economical point of view in economics. Normal, concrete and pure polymer.
Economics. At this point of time, I cannot comment because these are costly material. This is activators. That is costly material. That's why if you start working on it and one day, because you are completely eliminating the cement consumption, only cost towards this bindery is transport charges at this point of time. So if you take M30 grade concrete, roughly 350 kg cement, if I am using 5 bags, around 2,250 rupees I can save cement. But towards transportation of same point of fly ash, maybe 1,000 rupees or something, another 1,500 I am requiring to purchase these chemicals. So at this point of time, I cannot say that it is economical. But the days are not far away where you will definitely gain economy. This is monetary gain at the place where you are making the, but its impact on environment is valuable. You cannot quantify it, that effect. Pedestrian emissions, eliminating OPC itself is a big achievement. Of course, that is not directly impacting you, but globally it is giving impact.
But coming to practical and human, for the human beings and all, this budget is very highly.
Definitely. When it is coming slowly, definitely. See, initially, PSC, PPC were also thought of like that. Now they are interesting. We have to educate, that's our duty. We have to educate. Definitely it will pick up. Because the OPC can no more be expected. The resources are almost.
Thank you.
Sir, recently we visited JNU Kakinada. Professor Lakshmi is doing in same research, sir. She stopped testing 7 days, 14 days. She has found about a day. So,
That is also good. But at this point of time, I would like to compare every stage with respect to conventional concrete. How it is behaving. That is depending upon academic interest. straight away. How you, the results are comparable? Good. Sir, when it is heat cured at 80 degrees centigrade, it's enough. We are talking about curing. 80 degrees centigrade, 60 to 80 degrees centigrade, it's enough. But the $1 million question is how it is done practically when you are implementing that one. That's a problem. Sir, that has not related to durability aspects. Durability will be anyhow better for that is ambient cured or heat cured. The time you can buy. If you want the product to be ready by shorter duration, you better go by heat curing. Even if you can wait for some time, you can go by ambient curing. It is delayed. The product will be delayed also. Heat curing is obviously applicable only for precaution. Cash sensitive, it's not possible to go for heat curing. If you want to produce the concrete elements at a central plant, then you have steam curing chambers or heat curing chambers. Into them you will push these elements, wait for some time, they get cured and they attain strength and they can use. Any more? Thank you all for your patient hearing. I thank the organizers, management, staff, students, faculty members of Department of Engineering, ITAM, for having given me this opportunity to have an interaction with you all. Thank you. Thank you, sir.
Good afternoon, sir. My name is Rahul Aikina. Currently, my project is about self-compaction geopolymer. Is going on, and in the test, we are doing one is ambient curing and one is normal curing. In the normal curing, some of the specimens getting a lower value compared to the ambient curing.
Problem. See, it is interfering your this water curing is interfering your hydration process.
Acid.
That's why water cement ratio is increasing abnormally.
Okay.
By the time you are putting them in water curing, what is the condition of the specimen? Is it fully hardened? I mean, solid state rock-like material, or is it slightly jelly or?
Sorry, it means it is self-compaction. It means light slurries.
Probably it is not fully set, finally set.
Acid. It's
The
semi-solid.
setting time is a big issue. So I advise you not to go for conventional curing. If you are doing it immediately after 24 hours of demolding, this curing water will interfere your chemical reactions. They modify water cement ratio. If water cement ratio is increasing, what will happen? Probably that could be one of the reasons for your results.
Thank you, sir. Now I request Dr. Sausaniwani ma'am to act as repetitive for this session and to propose vote of thanks. Guru Brahma, Guru Vishnu, Guru Deva Maheshwara, Guru Sakshat Parabrahma, Tasmai Sri Guru Namaha. Scriptures say one word in Telugu, Talli Janmanistaru, Guru Punarjanmanistaru. Okay. So, respected dignitaries of the dais and my dear participants and colleagues, good afternoon one and all. Today's magnificent keynote speaker, Dr. K. Srinivas Rao, Professor of Andhra University, is my guru. Myself, Dr. Saujanyavani, Associate Professor in the Department of Civil Engineering Department, is a second research scholar awarded with PhD degree under his esteemed guidance. I am blessed by Almighty with such a superlative supervisor. So coming to the session talks about the geopolymer concrete, and it says OPC, 1 ton of OPC emits 7% of carbon footprint to the atmosphere. So we should have an alternative material. One such material is geopolymer concrete. So the entire session concentrates on the applications of geopolymer concrete and its fire resistant situations. Sir, we understood that GPC is zero carbon emission concrete, leaving extremely low carbon footprint on atmosphere when compared to conventional concrete under use. Being a renowned researcher in India in the subject concrete subjected to fire, sir, we are factually fortunate to have you here and to hear your lecture. And your lecture has concretely concluded that geopolymer concrete in situations like fire performs much better than conventional concrete, which is being used from past in construction industry. Thank you very much, sir, for enlightening us with the future sustainable concrete created in the field of civil engineering. I also thank each and every enthusiastic participant here. Thank you for giving me this opportunity. Thank you, sir. Thank you, ma'am. Now I request Principal Aitham, Dr. D. Vijay Kumar, sir, to come forward and felicitate Dr. K. Srinivas Rao Garu as a token of respect from our institution. Head of the department, Dinegar sir, and other faculty members, please join the felicitation.
పట్టుకురా
Participants, both years, especially if you come at 2 o'clock sharp. 2 o'clock.
Alive happy.
To the session
Oh.
starts. Please come at 2. We are noting the attendance. Participants from other